Hi, everyone. Welcome to this week's SIG schedule meeting. This meeting is being recorded, so be respectful to each other. It will be public in the internet. So today we have a tight schedule. Let's go through the list one by one. The first one is raised by Simple Shiho. He wants to do some experiment on using Wasm to see whether we can provide another kind of bundle system for the plugin-like extension. So his idea is wants to use schedule plugin as a starting point, but the overall approach might be general for all the Go projects that has sort of the plugin mod supported. So it's a long thread, but to be honest, I'm not a Wasm expert. So right now, I think the focus is that do we support this kind of sub project to be sponsored by scheduling or some other opinions here?
Right. The other alternative would be to do this in the scheduler plugins repo.
Yeah, that is another option. But given the long-term envisions that this kind of a general machinery as a general mechanism that can be have something pluggable to the Go project. So with that being said, I think maybe a standalone project may fit more, or you can say for now we can create a feature branch, and then by sometimes the test has been mature or something, we can just move to a standalone sub project. That can be also another option. So Aldo, what's your concern on supporting another sub project? So do you feel that we have way too many sub projects right now?
Yes, that's one concern. My other concern is that we already struggle with communicating what's the level of supportability of the scheduler plugins repo, and having yet another custom scheduler, because it's at the end of the day it's a custom scheduler. Having yet another repo for another custom scheduler within SIG scheduling is adds to the confusion of what's recommended.
I don't read it as another repo for plugins. I think it's another repo for general plugin experiments. So my point is that this project is for general experiments instead of just focus on schedule plugin. It's just that it's used schedule plugin as an example to try out the idea. So
I'm not following. I thought this was specific to creating Wasm plugins for scheduling.
Yeah, as I said, I read it as a starting point, and so Abdullah, what's your point on this?
I didn't really look at the request.
Okay.
And I think another concern is, yeah, back to the supportability. Is that we don't have enough visibility on the existing repos or existing subprojects about what's the maturity state Just adding one more, it complicates this communication.
I mean, do we actually declare a level of supportability to sub-projects? I mean, we sponsor them. It's the sub-project maintainers, you know, it's on them to decide, like, declare what is, like, it's not the SIG that's supporting it, the SIG is sponsoring it. I guess that's different, right?
Yeah, I agree with that. And also each project's intention is different. For example, like a queue, you may have some clear roadmap. It's a product, it's a out-of-box product, right? But for some project like schedule plugin, it's why it was initiated. It's supposed to be a marketplace for people to contribute their idea, implementation, design, but it's not overall treated as a out-of-box products. So basically, you can vendor, you can just use them as is. Right? So I don't think it's just too much for us to say, okay, what kind of maturity we can support for each sub projects. But yeah, I feel that yes, under SIG scheduling, we are sponsoring quite a lot of sub projects right now. But that is only just maybe one of the concerns. Other than that, overall, I'm more inclined to say, okay, Sambashiho has been improved. He's pretty experienced contributor in terms of scheduling, as well as some like Wasim extension mechanism. So I pretty trust him can host this project. So I'm basically +1 to give a green light to set up a sub project. But yeah, we can just have more opinions on this. I don't think we will impose extra maintenance efforts for the maintenance of SIG scheduling. It's well be.
So I guess then the question becomes, what does it mean for us to sponsor as a project if we have zero visibility of what's happening in the project?
That's a good question.
It's not that we don't have the visibility, it's that we don't have the time to, you know, to have some general knowledge of what's happening.
Yeah, that's a good question. I don't see it's clear documented in some architecture chart or somewhere. Maybe we can just, because of the time limits, we can just comment below these issues. This is our preference, and yeah, that's yeah. Okay, and the second one is because Sambashiho is not here, so the simulator, which is the first release, and if you're interested, take a look at the release notes, etc. And the third item is that discuss the methodologies of the architecture-aware scheduling issues. So, is anyone here in the meeting? I haven't read it.
Yeah, hello. Hi. Can you hear me?
Yeah, I can hear you.
Yeah. So let me go over that. So first of all, I'd like to introduce myself and a couple of my colleagues on the call. So my name is Prashant, and I have Alessandro and Jeremy with me on the call, and this is our first time on the call. So hopefully we do follow the rules and all of that. But so we to give you some context, we are working on OpenShift and specifically on the multi-arch compute effort, which is we are working to have OpenShift support a cluster with compute nodes of different architectures. We are seeing a lot of traction with cloud providers like AWS and Azure, who have now come out with ARM64 nodes. And we are getting a lot of users who are interested in them. And with that comes the question of every user would ask that why is my, like they would have this cluster up and they would say, why is my workload not working on this node? Like what is going on? My workload is crashing. And then we would look at it and we would tell them that, oh, your workload is x86 workload, but it's running on this ARM system. So we've had these kind of on this ARM VM it's landed on the pod has landed on the ARM node. So you have to set the node affinity. So unfortunately, we've had many cases where we've had to tell folks to do this, and there are recurring questions that are coming back to us with, can there be anything done in Kubernetes to make it more aware, to make it more intelligent regarding the architecture? And I know that this issue was raised before, and we did have a look at this issue. And we have actually been working now for a few weeks to on some proposed design solutions that we could potentially have in the scheduler or related to scheduling. So we were wondering what is the best way. So this, like, we want this to be kind of an introductory call where we present ourselves and we ask, like, what is the best way to go about doing this? We have some ideas, we have some proposals that we would like to bring forth to you, all of you, and see which ones make sense or which ones don't, or which path forward is the best to proceed. How should we proceed on this? So I want to open the floor to questions and also like what thoughts you have on supporting this kind of a functionality.
Could you give a very high level introduction on how you tackle this kind of problems? Yes, just very high level.
Yeah, so right now we don't have, as you know, like the only way that we are asking users to do it is to set the affinities in their pod spec to get around this issue. But we are floating around like a couple of ideas. One is we were thinking about having a scheduler plugin, an out of tree plugin, which could run in the filter phase. And it could have a pre-filter phase where it detects the architecture, the image is inspected and the architecture of the image is detected. And in the filter phase, the nodes are filtered based on the architecture, and the filtered list is sent across to the next step. So that was one potential solution that we were discussing about, where we could have a multi-arch aware scheduler plugin. There are other proposals that we are also looking into, like, for example, we could have a scheduler extender where the scheduler would query a controller, and it would hand off the work to the controller, which would then again inspect the image, and it would filter the nodes and give a subset of nodes back to the scheduler. And I know that there was some work done around pod scheduling readiness. So we could typically also leverage that as a solution where we set the scheduling feature gate for a pod and then have a controller come in and intercept the node list and do the work that we want it to do based looking at the image and filtering the list of nodes and sending it back and removing the scheduling feature gate. So these are some of the potential solutions that we have discussed, and we want to, we could also in future calls present a more detailed view of these solutions, but I just wanted to ask, like, what is the best way forward for this? Right? How can we proceed with this if we want such a thing to make it to the scheduler?
So first thing, the extender is not recommended because it's in the has some performance issues. Yes. So okay. It needs to exchange a lot of data between over HTTP. So it seems it's basically two masks. One is that you can just use the current existing scheduling primitive like node affinity or pod schedule readiness to tackle this issue. The other is more smooth and more more smooth that you can just impose a plugin to remotely doing this for you. So basically two kind of ways. I would say it quite depends on how you can handle these two solutions. If each node has clearly and you have a very good controller, or you already have some good controller running there and adding some extra piece to manage this kind of thing, maybe a very low hanging fruit for you. But if you want to start from scratch to build plugins, that is not trivial efforts. So yeah, quite depends on how much efforts you want to invest.
Yeah, I mean, I'll let Alessandro talk to it in a minute, but we have invested some work in the scheduler plugin method, and we have like I think a very basic, like a skeleton prototype of the scheduler plugin, where it inspects the image and then it filters like based on the nodes. It filters based on the arch. We were gravitating towards using the like a scheduler plugin just because it's in our mind it becomes very simple, like it just organically fits into the scheduler. We don't have to write a separate controller just for this purpose. All we need is already there in the scheduler, and the plugin already like the plugin pipeline already gives us all this information that we need, and it passes on all the relevant information. So it's just a matter of intercepting and inspecting the image to get the architecture. So we were leaning towards that. I'd like to understand why you think it's not, well, we are not saying it's trivial, but we are saying that is the method in our mind that requires less amount of effort rather than implementing a separate controller to tie in with the scheduler, which would then need to be shipped, etc., etc. And and ideally we'd like something that's organically that's part of this core scheduler itself, given that multi-architecture is becoming more of a thing now. We have seen more adoption in many clouds coming up with ARM nodes, and this seems to be like the future, where you will have nodes of different architectures or different types, and that's what we are thinking.
So back to your question about how to proceed, you could reopen this issue or create a new one and present your ideas in a document or in the issue itself, but you have to make sure that you answer all the questions that are already explained here, like how reliable it is, that you will positively get the correct architecture, and the authentication problems that Wei is highlighting right now. All of these details need to be explained before we can say, yes, this can be in the scheduler. And again, you can solve this out of tree. You can create a webhook that might work for you. But for a feature that has to go in the scheduler, it has to work everywhere, and it has to like we cannot add. Scheduler doesn't have access to internet today, right? And this will include a dependency on internet, right?
Yeah, but we are not sure how they tackle this issue. I mean, I think the key step is to figure out whether the workloads has the corresponding image available for particular architecture, and how can we know that in a very lightweight cast, there's some standard already out there. So yeah, it's pretty detailed, but pretty essential for the overall design, whether it can be fit in tree or out of tree. Yeah. But overall, plugin, if you want to go with plugin is yeah, it's a good way to proceed with.
So obviously our idea and the reason we are here is mostly to understand whether it's possible to, sorry, I'm Alessandro, by the way, I shouldn't present me before we are working together. And our idea, and the reason why we came here in this meeting is to understand whether it's possible to have it as an out of tree or in tree plugin, whatever. Obviously, by solving all the issues that you were discussing into the issue itself, of which the most key blocker seems to be registry authentication and the registry reachability, right? Because essentially for the images inspection, there was some discussion there about having suffixes, but if you assume to have manifest listed images or manifest based images, you can already inspect those images, accessing the internet, yes, or having the possibility to access the registry if you are in a private, right? The main point for us in terms of solving the issue behind the registry authentication and reachability is that we should agree on having the scheduler able to access the secret in the clusters, right? Because the image pool secrets can be stored at different levels, namespace level, port level, or even in the machines of the Kubernetes cluster that you're running on. And the scheduler should be able somehow to access those secrets. The ones at the level of the cluster, namespace level or port level, would need an arbitrary rule at that point. Is this a possibility that we can consider into an out of tree plugin? Probably yes, because it could be in the users to configure. But what about an in tree plugin? And another thing is, can we consider this plugin as disabled by default and make the users able to add some secrets to configure that nodes level credentials to access the registers? And finally, are there any cases that we can already access, and like test cases for which we can consider the different scenarios where the scheduler should work, in the sense that one can think also a cluster where some nodes are able to access a registry in terms of networks, not in terms of registry credentials, and other nodes cannot. But is this something that one should consider or not?
I think the short answer is that you should consider all the edge cases, and they all need to be written in your proposal before we can say if it's viable. I think, I don't know if this is the last thing you mentioned, but you also have to consider cluster autoscaler.
Yeah.
So that's why having the node affinity, somehow doing it pre-scheduling in a webhook, or I mean, it could even be an admission controller, but having that information written down in the pod spec so that the autoscaler can also use the same information without having to deduce it again or query the registry again and things like that. So the more information you can put in the pod spec, the better.
Okay, and this is why we were wondering about the entry plugin, because we know that the autoscaler can simulate the scheduler and execute the entry plugins or filtering plugins, but it cannot execute out of tree plugins. So the discussion should go about considering either a controller that will be able to provide information for the pod specs, and eventually, and maybe for I don't know, the autoscaler, some autoscaler expanders, maybe, unless you, I don't know, you use just the node affinities, and it is enough for the autoscaler, or having it as an in-tree plugin that the autoscaler can use to simulate the autoscaling of nodes with the proper architectures.
And I think the simplest architecture would be that the node affinity is there. If you can get to a design where the affinity is there, then cluster autoscaler doesn't need to do anything else.
Yeah, it seems in their case, they are capable to recompiling the autoscaler with the custom plugin. So the autoscaler is aware of the custom plugin. So that seems to be fine with them. But again, so it's basically, if you trigger the autoscaler, you have to assume that if you rely on some internet access, you have to assume that because autoscaler have the same internet access to the registry to get the same kind of information. Otherwise, although you reuse the plugin's logic, but the topology network issues are different, that may be.
That case would be so to use things like mutable or directives. What's the mutable scheduling directives, right?
Yeah.
And external controller to change the pod specs. It would be mostly a downstream solution, not involving the SIG scheduling at all, right?
Yes, or it could be a webhook, or it could be an admission controller in API server. I think we are not admitting new ones, but that's something that can be discussed with API machinery, whether we can include more admission controllers to do this kind of behavior. I think that, yes, I think the point of the in the thread, the main point is that well, it's not the scalar's responsibility to know what's the architecture of an image, or it's not trivial to obtain that information. So yeah, please share your proposal, but it needs to answer all these questions that are already there.
Okay, that sounds good. Thank you. Anything else,
Thank you.
Alessandro or Jeremy? Anything you have?
No.
Okay, thank you.
No questions, no comments. Thanks for the feedback. Good to meet you all.
Thank you.
So, okay, the next one is Aldo. Do you really want to bring it up in our meeting? It seems a pretty old issues, and for downward, that doesn't sound like related with scheduling. So, what's your take on this?
So basically, the quick idea is that a pod could have access to the topology labels, so that it can it knows where it is. It knows which other pods that belong to the same job are close or in the same zone, same topology, in the same topology domain. So that's the overall desire. Now,
wait. Isn't that the downward API is happening after the pod is bound to a node? So that means the pod has been bound, and then.
Yes, but the downward API only has access to the pod labels. It doesn't have access to the node labels.
So does that mean this will benefit the runtime thing instead of scheduling?
Yes. So this is the desired outcome. Now, coming back to implementation or solutions, one potential solution is that at pod binding time, when we assign a node name to a pod, we can copy the topology labels, the well-known topology labels, into the pod. So yeah,
what's the benefit for scheduling? Because if a pod has been bound, we know the node information, and the node has the label, topology labels. So schedule already has the information.
Yes, the proposal here is that the binding API, in addition to setting up the node name, it also sets the topology labels. And then the pods can use the downward API to access those labels. Yeah, that's one of the proposed solutions by Tim Hawking. It's kind of one of the last comments. Yeah, we don't have much time to discuss it, but I think yeah, if you have a look at this, maybe we can think whether this is a good solution, and if so, we can implement it in the binding API, in the binding endpoint, which we own as SIG.
Yeah, that seems funny. The binding piece is only owned by SIG scheduling. Other than that, like the benefits seems more in the runtime of the pod runnings, because the workload itself can leverage this kind of downward API environment, variables, values, get more performance or etc. application boost.
Yes,
okay,
yes, that is correct. That is correct.
Yeah, sounds good. Sounds good. Okay, the last thing is we are doing some planning for the next release. So Ado and Abdullah, so given we only have 10 minutes left, do you think we can maybe leave it to the next meeting? Because it's still a lot of things to discuss. Or you just want to go a quick go through with this?
Yeah, we can do a quick
okay.
listing.
I will see what, so the first one, I will give a very high level introduction. The first one is, we have already implemented some similar directive in topology spread, which is mainly for some scenario like the rolling upgrade. So that mechanism can be generic to other scheduling directive we already provided, like the pod affinity, pod unaffinity. So that is, this issue is for that. And it didn't catch the last the train of 127, so we're gonna to target on 128. I'm gonna to review and approve it. For the other three, like I said, it's not this one. Like I said, pod topology spread and has two fields that can get more benefits during the ring upgrade. So those two are already beta, and we don't have plan to promote it to GA yet. And for post scheduling readiness, because it's beta in last release, so we don't consider getting it to GA too soon. So those three features will stay in beta for 128. And this one is dynamic resource allocation. So it's a cross multiple SIG, and definitely scheduling is also one important area. So Patrick is owning that, and I don't know his plan yet, maybe not to promoting 128, but he has done a lot of good things, amazing things in the scheduling improvement as well as the scheduling performance test framework. And so, by the way, this one, the feature overall is to want to generalize the PVC pattern to any generic resource, so it's called dynamic resource. And after that is another one for preemptions optimization. I think the last release we didn't make it is because we didn't make a consensus on some API design. Is that correct, Ado?
Yes, I think the concern was that the API was too permissive.
Okay, so yeah, we are trying to get that resolved in this release. So this is for the PDB, whether it's a required guarantee or best efforts. And the last one is a new one, not that particular with scheduling, but some of the code I think we can own. So the history is that in the before, whether how you label to, sorry, add tense to a node, and how you honor the effect of the tense are just bundled in one component called node lifecycle controller. So here I just meant the no execute the tense. But there are some scenarios users want to separate them and to provide more customization, etc. So this cap is basically for that. So I'll be volunteering to review this. So basically, this is the overall list of the caps we're going to have in 128. But if you have some other new or I missed something here, just raise it up in the Slack channel. We can edit it and to our radar. Other than that, yeah, any questions for anything else? Just feel free to raise your questions.
Regarding match label keys, I was talking to Aldo yesterday.
Mm-hmm.
It only enforces, like, allows us to do like n semantics, right? Like, assume that I want to do not n myself. For example, I don't want to have, like, imagine having pod anti-affinity term, but I want to exclude myself, right? Like, just something
that is, yeah, that is one behavior we shouldn't break. So in the original, I think it's still the current implementation is that for pod anti-affinity, if it's the first part,
no,
it will
like,
just.
Yeah, I understand that, but like, if I want to do anti-affinity so that I don't, I still want my group, like, so I have a job, I want to implement exclusivity, I want to repel all other jobs, I want to be the only one in that topology domain, right? So how would you do that? You say, okay, I will install, I will add a pod affinity to myself, right? And anti-affinity against all others.
Yeah.
And the way that you do anti-affinity against all others is by saying anyone has, for example, job name set, that should be excluded, right? It shouldn't collocate. But then but I myself has that. So how do I exclude myself? Not myself, like my job, not the pod itself, like the job itself. You see what I'm saying? So you say, I have anti-affinity against every pod that has job name set, unless the job name is equal to me. So if I if you were to do it in a generic fashion without specific, like, explicitly setting my job name, you want to do something like not in match label keys job name. Basically, not like you fetch the label from the pod that is being placed.
I see your point.
It's a bit complicated, not too straightforward to think about. But I was looking at the implementation for match label keys, and it's basically, it's only about the operator n. That's it. That's what it supports, right? Like, if you have an anti-affinity or affinity that says that sets the match label key, we add a constraint that says label equal myself, right? That's it. But there's no way to say not in, like to revert it. Anyways, yeah, that's, I don't know if I guess this can be, yeah, I don't know. Like, I need to look closely at the API, if it is possible to actually specify such a thing. Like, you set match label keys to the label key, and then at the same time set the operator, and the operator would decide but I don't think we have that level, right? Like of because match
Yeah,
label.
we don't because as a term, as the name says, it's part and have anti-affinity. It's not job anti-affinity. So
No.
basically, you want to achieve semantics of like we have a job anti-affinity. Is that right?
Yes, and that's why we have pod anti-affinity. Right? That's why you group them using a label key.
Yeah.
That's how you.
Yeah, let's see how it can achieve the goal.
Anyways, all right.
Yeah, sounds good. Interesting. Okay, I think we are done for today's meeting, and yeah, I'll give you 2 minutes back, and yeah, let's chat in the next meeting. Yeah, thank you everyone for your efforts.
Thank you all.
Thank you.